Hi, welcome to the video on single phase circuits. So, single phase circuits, let us start with the AC fundamentals. So, in this video, we are going to discuss on generation of sinusoidal voltage, working principle, and advantages of purely sinusoidal waveform, and also the advantages of AC over DC. So, before starting with the working principle, let us understand the generation of sinusoidal voltage in a simple manner. As we all know, the basic principle of an AC generation is the principle of electromagnetic induction. So the sine wave is generated according to Faraday's laws of electromagnetic induction. So how this sine wave is generated according to the laws of electromagnetic induction. So for that, we need to have a small construction here. In this, let us take a two magnets, okay? Let us take a two magnets and we have the magnetic field. Let us say this is north and south pole, and let us say we have a conductor placed in this, and this conductor is coupled to the shaft and further to the rheostat, just to indicate. So these two circles are called slip rings. So we have a brushes here under this. Let me have a brushes in a different color. So brushes under this. So this construction, it consists of a permanent magnet having two poles. So as I said, north and south poles. A single turn rectangular coil is kept in the vicinity of the permanent magnet. So the blue color, rectangular, shape, we need to understand that as a coil which is kept in the vicinity of the permanent magnet. So the coil is made up of two conductors. So if you look at this, this is one conductor, the horizontal portion at the top, this is one conductor and this is one conductor, and jointly forms one turn here. Okay. So the coil is made up of two conductors, namely A and B. So let us name this side as A and B and this side as C and D. Okay. So C and D, or you can say this one as C and D. We say this A, B side, and this one as C and D. So this is made rotated on its own axis. Okay, the center line is called the axis of this rectangular coil. So this is made to rotate on its own axis. So remaining two ends here, okay, of the coil are connected to the rings. So if you observe the two ends here, let me call this as C1 and C2. So these two ends are connected to the rings mounted on the shaft called the slip rings. So the two brushes here, P and Q, so which I indicated in orange, this is P and this is Q. So these two brushes are resting on the slip rings. So the brushes are stationary and just making contact with the slip ring. So the brushes is just a stationary one. So it is not rotating, but the slip ring will rotate as the conductor or the rectangular coil rotates here. So the working principle says that the coil is rotated in anti-clockwise. So I'll come up with the next slide, imagining a coil rotating in the anti-clockwise, and the conductors AB and CD will cut the lines of flux. So if you observe, when you rotate this, you need to have an imaginary vision to understand this concept. When you rotate this rectangular coil ABCD, okay, in an anti-clockwise direction, it cuts the magnetic lines of flux of the permanent magnet. So according to Faraday's laws of electromagnetic induction, an EMF is induced in this conductor. So this EMF will drive a current. So EMF, electromotive force, is nothing but again a voltage, will drive a current through the resistor R. So it is understood when the current here flows here, it is understood when a current flows to this resistance, it is understood after rotating the rectangular coil, it is understood that once the rectangular coil cuts the field, a EMF is induced, and because of that EMF, the current is flowing in the resistor R here. So with this indication, it is understood when we rotate the rectangular coil in a magnetic field, it cuts and EMF is induced, and because of that the current is flowing. So the current driven by the induced EMF reverses direction periodically as shown in the next video. If you look on to the next video here, so I will just play. So imagine this conductor is rotating in an anti-clockwise direction. So after EMF getting induced, so if it is reversing the direction periodically, so sinusoidal wave is formed. So because of the EMF, the current is driven here in the resistor. So we can write the current, if for any given voltage, okay, for any given voltage, V is equal to Vm sine omega t, current will be also I is equal to Im sine omega t. So for any given voltage, so if you take V is equal to Vm sine omega t, the current is also produced because of the EMF induced, that is I is equal to Im sine omega t. So advantages of this purely sinusoidal waveform. So in a sinusoidal wave, even after repeated differentiation or integration, it remains a sinusoidal of a same frequency. That is the first advantage. Second advantage, applying sinusoidal voltage to properly designed coils result in a revolving magnetic field which is capable of doing work. So majority of electric motors used in commercial and industrial applications works on this principle. The third advantage here, using sinusoidal voltage underlines the operation of transformers which enables bulk power transmission at high voltages over a long distances. So the fourth point, most importantly, when a sinusoidal current flows through the capacitor, an inductor or a transformer, the voltage across the element is also sinusoidal. So as I said, for any given applied voltage, if it is sinusoidal, the current is also sinusoidal. Now the very important aspect here is advantages of AC over DC system. So what are the advantages of AC over DC? The first advantages of AC over DC is, the first advantage, AC voltage can be raised or lowered. Okay, AC voltages, I'm talking about anything with respect to AC. So the AC voltages can be raised or lowered using a device called transformer. Okay, so that is the one good advantage we have, where DC is not possible. So it is not easy when it compared to DC system, but in AC system we can raise the voltage or lower the voltage, using the transformer. Raise the voltage in the sense, suppose if I want from 11 kV to 400 kV, I can raise the voltage, or I can lower from again 400 kV to 11 kV. So vice versa, there are certain standard voltages where you can raise and lower. So we can't talk about whatever the voltages we think of. There are certain electrical standards of voltages where you can raise and lower. So I'm talking in that sense here. The second advantage, it is possible to build up high AC voltage and high speed AC generators of large capacities with less construction cost. So construction cost is less in case of AC. Okay, construction cost is less in case of AC when you want to build an AC generator, okay, of large capacities. And the third advantage is electric motors are simple in construction, cheaper and lower maintenance. Okay, AC motors, okay, are cheaper and less maintenance. So as I said, these are the main advantages of AC over DC system. In the next video, we shall discuss on standard definitions and of a sinusoidal function, or standard definitions or terminologies what we use in single phase circuits in the next coming video. Thank you for watching.